Alright, so let's start this lecture. Before that, there was a doubt in the last lecture that how the temperature is constant in case of Gibbs free energy, right? When the Gibbs free energy is the discussion of our interest, then how the temperature becomes constant in that case. So since I haven't shown you the derivation, that's why this doubt arises. But I have shown the derivation for Helmholtz free energy, right? We know that we know this thing, that work done is equal to minus of delta F. So the work done by a system undergoing an reversible isothermal transformation is equal to decrease in F. So at least at this level, you know, right, temperature is constant. That then only we have this equation holding, right? This is clear. So this is the point when the temperature comes into the picture and temperature is fixed. Now from here only we will derive the Gibbs free energy, the expression for Gibbs free energy that we have derived, that is G equal to U plus PV minus TS, or U minus TS plus PV, just rearranging them. So yeah, if we do some steps from here, then we can see that we will have a function that is called Gibbs free energy, and that function comes there, and temperature is constant at this point. So let me show you those steps. It is not that much hard. So if you see, since delta W equals minus delta F, okay, so we know that delta W is nothing but P delta V, that is P of V final minus V initial, this one, okay. So if you put this thing in place of this, what do you get? It implies that P of Vf minus Vi equals minus delta F. Also we know F equal to U minus Ts. So delta F will be just delta U minus, since T is constant, so we can't do delta T, but T will come out as the constant value, so S will become delta S. So delta F we can write like F of final minus F of initial. Similarly, U final minus U initial minus T of S final minus S initial. So this delta F can be replaced by this thing. So let's do it. Plug equation 3 into, what do we get? P Vf minus Vi equals minus of this whole thing, sorry, this whole thing, ऐसे. Now collect the final terms together and initial terms together. So if you see in the RHS, in LHS you will have P of Vf minus U of F, है ना? Then minus of TSF. Similarly, you will have P of Vi, because I am collecting I terms in the right hand side, so this will become this thing. Now introduce G, which is a thermodynamic function, because it is dependent on the thermodynamic variables. So G equals U plus PV minus TS, right? So if you see, this thing is nothing but G of this thing is nothing but G at final, and this is nothing but G at initial. It implies that G final is equal to G initial. So this was the case, right? But this is happening for reversible process, right? That is why the equal sign is there. But if we consider in general, if we want to take reversible as well as the irreversible thing into consideration, so we will have this thing. We can replace equal sign with this inequality sign also, like this. Okay. Fine. Yeah. So the last one will also become G of F is less than equal to G of I. Or you can write it at delta of G is less than equal to 0. ये proof हो गया हमारा. Okay. So this is how this temperature comes, and remember we have assumed that here pressure is also constant. In this whole calculation, pressure is also constant, and G is the same Gibbs free energy. This is how we define it. And this equation, what does it tell? It tells that the Gibbs free energy in the final state cannot be greater than in the initial state. So it means that when G will become minimum, that will be the stable equilibrium for the definite set of T and P. T or P throughout this process are constant. Okay. So remember P is constant here because otherwise we could have written P of F, है ना? Or T of F, or P of I and T of I. But because they are constant, so I or F both in the both cases they are same. So I think I have cleared your doubt. If you have still some and this is why we call it Gibbs free energy or thermodynamic potential at constant pressure. Or if you have still some doubt, you can see that W equal to PV PdV होता है, right? है ना? तो the moment we have written delta W equal to P delta V, है ना? So it means that we have taken P outside. ऐसे यहाँ पर आउटसाइड ले लिया P, इसीलिए आउटसाइड लेने का मतलब ये कि कांस्टेंट है ना? इट इज़ नॉट डिपेंडिंग ऑन वॉल्यूम और समथिंग एल्स. Fine. So now let's move towards re-derivation of Maxwell relations. Like I have promised in the last lecture that with the help of thermodynamic potential and the mnemonics that we have constructed in the last lecture also, that can help us to derive Maxwell relations within seconds. Okay. So if you are asked in the exam, so maybe this is the best way to do this in the exam, and I hope I also believe that most instructor in the class also derive with this way. Okay. So let's start it. So the heading is re-derivation of Maxwell's relation. ठीक है. So for this, if you remember the mnemonics, if you remember, not just remember, if you know how to use the mnemonics, then you can do this thing easily. So let me just reiterate the mnemonics. That is, great physicist has studied under very fine teacher. Okay. So now I need to connect the potentials with the thermodynamic variables, this and this, and U will connect in this way, and H will connect in this way. So first of all, let's start with the first thermodynamic potential. Let's start with the internal energy. Okay, so where is internal energy? This one, and it is connecting volume and entropy. So these are the natural variable of thermodynamic potential U. Okay, so U, just write U as the function of S and V, like this. Okay, so you can write du equals del U by del S at constant volume into ds plus del U by del V at constant entropy into dV. Fine, you know this? Good. Also, with the help of mnemonics, what can you write? du equals, it is connecting to the volume and entropy. So what is the pair of V, the element or the इसका cousin कौन है? इसका cousin है P. So it will be so first of all the differential will be dV and ds, but since dV is the in the left side, it will come with negative sign. So minus pdV plus tds. Okay, so this is there. Fine, let's call it equation number 1 and this equation number 2. Now use the property that okay, let me write, since du is the exact differential, therefore इसका डेरिवेटिव, हमने पहले स्टार्टिंग के लेक्चर्स याद करना, द मैथमेटिकल प्रीरिक्विजिट्स, जहाँ पे मैथमेटिक्स की रिक्वायरमेंट हमने बता रखी थी, तो इसको हमने mxy बोला था, इसको हमने nxy बोला था. ठीक है, तो हमने बोला था कि जो ये कोफिशिएंट होगा उसका डिफरेंशिएशन, दैट इज del u बाई del s एट कांस्टेंट वॉल्यूम, इसका डिफरेंशिएशन विद रिस्पेक्ट टू v, जो दूसरा वेरिएबल है. ठीक है, ये दिस थिंग, राइट, आई होप दिस थिंग इज करेक्ट. हाँ, तो ये चीज़ जो थी वो किसके बराबर थी? डेल बाई डेल इस कोफिशिएंट के बराबर थी, डेल बाई डेल एस ऑफ डेल यू बाई डेल वी एट कांस्टेंट एस. ठीक, और ये जो पूरा है इस पे क्या कांस्टेंट है? एस, और इस पे क्या कांस्टेंट है? वी. अगर ये क्लियर नहीं हो रहा है तो इट मीन्स यू हैव फॉरगॉटन द कॉन्सेप्ट इन द प्रीरिक्विजिट्स. ऐसे ही नहीं बना रखे थे प्रीरिक्विजिट 1 आवर्स के. ठीक है, सो नाउ व्हाट इज दिस थिंग? नाउ दिस थिंग इज नथिंग बट टी, है ना. अगर इन दोनों को कंपेयर करो, सो डेल यू बाई डेल वी एट कॉन्स्टेंट एस इज नथिंग बट माइनस पी, और डेल यू बाई डेल एस एट कॉन्स्टेंट वी इज नथिंग बट टी. सो यू कैन रिप्लेस दिस थिंग, हाँ, with t. So del by del v or del t by del v at constant s is equal to, what is this? This is nothing but minus p. So minus del p by del s at constant v. So this is your one of the Maxwell relations. I hope the process is clear. It is easy peasy. If you are stuck at this point, it means your previous concepts are rusty. You need to revisit those lectures or rewind those lectures. Whatever way you want to do, you should do it. I should not emphasize that thing again and again. Fine. So now let's use the second Maxwell potential. 4 Maxwell potentials हैं, तो 4 each Maxwell potential will give you one Maxwell relation. So 4 will give you 4, of course. So let's use the second one, that is Helmholtz free energy. So f, what are the natural variable of f? You don't need to remember, you just need to remember the mnemonics. F is connecting T and V, so T and V are the natural variable of Helmholtz free energy. So first step, df is nothing but that, since it is exact, or in general you can write in this way, df in this case is nothing but this. This is equation 1, right? Also using mnemonics you can write df is dt or dv are a differential, and what is the cousin of t, that is s, इसका cousin क्या है, p, so it is simply minus s dt minus p dv, because both are in the negative direction. So by comparing 1 and 2, ये वाला पार्ट मैंने ऊपर नहीं किया, अभी करूँगा तो थोड़ा और समझ में आएगा कि del f by del t at constant v is nothing but s, ओके, माइनस एस था तो एस को मैंने नेगेटिव साइन को मैं वहाँ ले गया, और del f by del v at constant t is nothing but p, but negative sign is here. Now use the property that it is exact differential. Since df is exact differential, so इसका differentiation with respect to v at constant t और इसका differentiation with respect to t at constant v, both will be same. Del by del v of del f by del t at constant t is equal to del by del t of del f by del v at constant t whole constant v, right? This is the property of the exact differential. Now you can replace this thing by minus s, this thing by minus p, ये और ये, okay? If you do this, what do you see? You see that del f by del t at constant v, that is minus s, और ये minus p, negative sign will cancel, so this is the next Maxwell relation. You can check it out. This is how you can derive the second Maxwell relation, okay? So in the same way we can do third and fourth. Maybe I can do one more, but the last one you should do by yourself, so that you can also get a taste of the process. So let's do the third one, enthalpy. You do with the Gibbs free energy, okay? So what are the natural value? Since natural value of h are, I don't know, I don't remember, because I just remember the mnemonics. Let's go to the mnemonics. P and s, both are in the positive direction, P and s. Therefore dh equal to del h by del p at constant s into dp plus del s by del s at constant p into ds, equation 1. Also dh equal to let's see the mnemonics, but I know you can do it now. So it is del s by del p है ना, तो सॉरी ये dp है और ये ds है, तो इसका p का जोड़ीदार v, इसका जोड़ीदार t है ना, v dp और s t ds, या okay. Again compare 1 and 2. if you compare 1 and 2, you will get this thing equals this thing, and this thing equals this thing. EG PG. Okay, using the exact differential, using the fact that dH is an exact differential, so इसका differentiation with respect to S at constant P is equal to this इसका differentiation with respect to P at constant S. So just replace these two things here and here. So you will get del V by del S at constant P is nothing but del T by del P at constant S. This is your again one more Maxwell relations. Fine. I hope you can do with the last one, that is Gibbs free energy. And there should be no difficulty in deriving it.